5.1, the natural logarithmic and function differentiation. So we're going to differentiate the law functions. So what is objective? Develop and use properties of the natural logarithmic functions. Understand the definition of a number e. Did you see that? It doesn't say variable e, it says what? Number e, because e is a number. It's an irrational number. Find derivatives of functions involving the natural logarithmic functions. Natural log functions. In general power rule, look at this. In general power rule, if you have an x, integral x to n dx, that gives you what? M plus 1, m plus 1 and divided by what? M plus 1 and plus c? Right, but this will fail if you have a what? This power. If it's this. Then can you do your calculation in your head? If you had this.
Right.
Okay, you get a what? This is the same as x to what? Negative 1 dx, isn't it?
Right.
So if I use a power rule, what do I get here then? So x to what? Negative 1 plus 1 divided by what? Negative 1 plus 1 plus c. Let's finish it. Numerator is fine. Numerator is 0 power. What happened to my denominator? Can I have a denominator to 0? No. So we fail this. So we cannot do this. We cannot simply use a power rule. Are you with me, class? That's why it comes what? Logarithmic functions we gotta do. So we're gonna use whenever you have a 1 power, which is negative 1 power, excuse me, you should say negative 1 power, then we're gonna use log. I didn't even talk about it yet. We're gonna talk about it in a. So this is it. So whenever, there it is. So if you have 1 over x or 1 over t, you have that. Your log is what? When you do the integration, what you get? Natural log of x. Are you with me? So in other words, if I give you function 1 over x or x to the negative 1, if I integrate this, what do you get? Natural log of x plus 1, c, that's what you get. So in other words, if you have a negative 1 power, you don't take a power rule. This becomes a logarithmic function, so we're gonna do the what? This becomes just the natural log of x. Are you with me, class? That's what it becomes. And natural log looks like this. So anyway, this is a function looks like this. All right? So if I look at the natural log function, this is what it looks like. Natural log of x, this is what your function looks like. Let's look at the domain and range. What's my natural log domain? Domain is where? 0 is not included, right? And then it goes all the way to where? Positive infinity. So my domain for this is negative, 0 to what? Positive infinity. What is my range? Starts at where? Negative infinity and goes all the way up to where? Positive infinity? Yeah. So that's domain and range with natural log of x. All right, what else do you know? Natural log of 1. Natural log of 1 gives you, natural log of 1 gives which number? Look at the graph. Natural log of 1 gives you which number? You plug it in natural log of what? 1, what's your y value? 0. That's right. Memorize this. Okay? Natural log of 1 is equal to what? 0. So they were giving you, we just looked at it, so they're going to summarize for you properties of a natural log function. The natural log function has following properties. What is it? The domain is what? 0 to infinity, which we saw in the graph, right? Range is what? Negative infinity to infinity. The function is a continuous increasing one-to-one function. Okay, let's look at what that means. Let's look at this function. It's continuously what? Growing. It's positive slope. Every place is what? Positive slope. Are you with me, class? It's continuously growing. What is one-to-one means? One-to-one means I can do a vertical test and horizontal test. They both only pass what? 1 point. So if I draw a vertical line or horizontal line, when I draw the horizontal line, you get what? The graph passes only what? 1 point. I'm gonna draw another just the vertical line anywhere. I decide to draw right here. How many the graph is only passing what? 1 time on a vertical line, isn't it? So that's why it's called 1, 2, what? 1. Your horizontal line give you only 1 point pass. Your vertical line only passed what? Only 1 point. That's why it's called 1.1. I mean one-to-one function. So in other words, natural log function is one-to-one function. So that's why it says function is continuous and it's increasing, and this is what? One-to-one function. The graph is a concave downward. Let's look at that. Does everybody see it? It's what? It's concave down, right? What's a concave up means? Like this. So this is definitely what? Concave down. It's just the properties I want you to know in case you need to utilize this to solve other problems. Another thing, this is the properties you need to know, otherwise you cannot do your homework because it's going to ask you to do other stuff. So if A and B are positive numbers and n is rational, then following properties are true. Natural log 1 is what? 0. We saw that, right? What else? If it's natural log A times B, I can make it into plus problem. It's very important, yes.
Can you put that on your calculator? I hit the button and say ln. Is that the same thing?
Yes, ln is the same thing.
Oh, cool.
So A and B is a number. In that case, you can put in your calculator to figure it out. If they give you a variable, then you cannot use your calculator. Then you have to do by hand, using the definitions. One more. There's 4 properties you need to know. If it's natural log A times B, there's 2 numbers. I can make it into what? Natural log A plus natural log of B. Next one. Natural log A to the n. That's the power, A to the n. Then I can bring the n in the front to make n to be your coefficient. This is a very, very important. You gotta use this property to take a derivative. This makes it much easier than taking a derivative over this. So always make it into, if you have a power, you bring down in the front to make what? Coefficient. Coefficient is much easier to work with than a power. Okay? This makes sense, right? This and this is opposite, right? So natural log A divided by B. If it's divided by B, then what do you do? Subtract. Just like what it says. Remember, multiplication become a what? Plus. And division become a what? Minus. Right? Is everybody with me? A divided by become a minus. Multiplication become a what? Plus. It's easy to memorize. All right, they gave you this problem. Look at that. I gave you natural log 10 divided by 9. I can make it into what? Natural log 10 minus what? Natural log 9. All right, look at this one. I have a square root. I'll make that into what? Power of this. So 3x plus 2 to 1/2 power. Now what can I do? Move in the front. That's right. 1/2 in the front. So I have this. All right, next one. I have a natural log 6x divided by 5. So first thing I'm going to apply this. Are you with me, class? So I have natural log 6x minus 5. Can I expand more? Yes, remember multiplication? This is just 6 times what? X. So can I make it to be what? Natural log of 6 plus natural log of x. Does everybody see that? So I'm just giving you examples so when you do your homework, you know what to do. So watch this one again. What did I do? If you want, okay, if you want, you can do natural log 6 plus natural log x, and then what? Minus natural log 5. That is also fine. So important thing is what? You can break it into what? 3 terms. Right now, this is only 1 term, right? But I can make it into what? 3 terms. Because having this is much easier to take derivative than taking a derivative over this. All right, that's the reason we're gonna make our problem simpler. All right, look at this one. Do you want to take derivative of this kind of problem? Probably not, right? It looks very complicated. So what I need to do is what? Make it into simpler part. Oh, in class, don't forget to sign your name.
Thank you.
Thank you. All right, first thing first, what am I gonna do? How about I make this division into what? Subtraction. So I put this minus what? That. Is everybody with me? Next one. I probably like to do what? Bring this 2 in the where? In the front. All right, look at this one. This, okay. This person did everything at one time, so let me take this one away. So everybody understand about this part is what? This is the same as 2 natural log x squared plus 3. No big deal. What about this one? That is the same as natural log and then what? X times, did you see this one right here? What is this one? This is the same as x squared plus 1 to the what power? 1/2 power. Does everybody see that?
Why is it not 1/3?
Oh, 1/3, 1/3, yes, 1/3. I like square much better than cube, you can tell.
I don't blame you.
All right, it'll be a Q power. Does everybody see that as Q power?
Mhm.
Okay. So I don't have to do anything to this. Everybody with me? That's already expanded. I just rewrite again. What about this one? This is a multiplication, so can I make it into a addition problem? Let me make a bracket here, so I can put everything. So I have natural log x plus what? Natural log x squared plus 1 to the what? 1/3. But I'm not done yet.
Could you bring the 2 in front?
I'm sorry?
You can put the 2 in front of the LN?
Oh, not the 2, which one?
Oh, the half?
1/3.
Oh, the 1/3? Okay.
Yeah.
I like 2's too.
Okay. This 2 here, I cannot bring in the front. Why not? Because this is connected by what?
Oh.
Addition. You can only bring your power if it's what? Everything does that power. Like this one, I didn't bring down in the front.
Okay.
Because this is x squared plus 3, not x squared by itself.
Ah, okay.
Do you see the difference?
It has to be by
He
itself.
just asked me very important things. Did everybody see that? Natural log of x squared, I can bring it to be what? 2 natural log of x.
Oh, that's how
Right?
you wrote it, yeah.
Is everybody with me? Or can I do this? Can I do this? Can I do that?
No.
No, why not? This square power is not a square to everything.
Yeah.
Yeah,
Is
okay.
everybody with me?
So we got-
This is only square to the x, so I cannot bring in the
Oh.
front.
Okay, I got it.
That power has to be what? Everything to that power, then I can bring in the front. Does everybody see that?
Yeah.
So this 2 is only good for what? X. What about the 3?
No.
See that? That's why. So it's not true. Only this is true, okay? That's very good.
Thank you.
So people get to see the difference. So now, I just bring this down again. Now this one. So now natural log of x, because of negative sign, this is a natural log x squared plus 1. And what can I bring in the front now? 1/3. Does everybody see that?
Uh-huh.
Does everybody also see I distribute this negative sign to here and here?
Change the sign.
Right, so that's why because natural log become a what? Negative natural log, this become a what? Negative. So that's it. So you can make this problem into this, then you can take derivative much easier. Is you following me, guys? Are you guys following me? You want me to erase now? You good?
Exactly.
What is it?
I wish I can. We was talking about how we understand it.
Okay. So did everybody see how they got this one right here? They make it into 2 parts. And then one more step, put in the 1/2. Does everybody see it? So same thing we just did. All right. One thing you have to realize, okay, this function right here, it's a natural log of x squared. This looks like this when you graph. Because it's x squared, that means I can use negative x and I can also use what? Positive x, because x squared makes everything to be what? Positive number. But if you bring down this in the front, you get a 2 natural log of x, right? That graph looks like this. Only have a what? Positive side only. Your negative side will disappear because you only become an x, not x squared. They are different pictures. So domain has to be given. All right, the number e, the irrational number e. By the way, when you look at your calculator, it says log 10, what log? The log is what base? Base 10. So your base and your argument is the same, they become a 1. So if I give you this, log base 2, how can I get 1 here? How can I get 1 as my answer? That's right, your base and an element has to be what? Argument has to be what? Same, then you get a 1. But your calculator just use base 10. But problem usually give different bases. Like a natural log e, the base is e. Okay, natural log, its base is e. When you see natural log, all right, its base is what? E. So it's like e2, you give you what? 1. All right, so e is equal to 2.71, blah, blah, blah. This is an irrational number. Are you with me? That's an irrational number. Natural log e is 2.7, it's about right here. Where is it? Something like that. As you see, natural log of e is what? 1, because natural log base is what? E. All right, so this is another thing. Definition of e. If I give you 1 over t, but your upper bound is e, then your answer is what? Natural log of e. Remember, if I give you 1 to x, they give you what? Natural log of x. But if your base is e, then what do you get? Natural log of e give you what? 1. Because natural log base is what? E. All right. So you got this one. So if they ask you to solve this, then what do? You bring the n to where? In the front. So natural log e is only once. N times 1 is what? N. So you just got this one. Natural log e to the n is the same as what? Just n. And this is evaluated numbers. 1 to the e to the negative e to the 3 give you this. But that's the same as what? Negative 3. Natural log x. In this case is what? See, everybody see it? If I give you this, you can bring this down to where? In the front, so you get a what? Negative 3 natural log e, which is negative 3 times 1, which is what? Negative 3. That's what they're showing you. All right, let's look at this. Well, natural log this. You need to evaluate this one using what? Calculator. I cannot do this problem pen and pencil, so you have to put it in your calculator. So yes, so you don't need to have your calculator, or you gotta have what? A Julia box. Natural log 32 is this. All this thing you can just, these problems, I don't mind using your calculator to do it, okay? It's fine with me, just use calculator. But if the problem gives you certain things to use it, then you have to follow that. Some of your homework will have that. They give you some definitions and say use the definition to solve your problem. And I'll show you. You will probably ask me as your homework problem. The derivative of a natural logarithmic function. This is important right here. Derivative of natural log of x is what? 1 of x, which makes sense. Remember we just did it. We said 1 of x, dx give you what? Natural log of x plus c, remember that? So I'm going backward. So derivative of natural log of x is what? 1 of x, of course. And derivative of natural log of u, okay, u means chain function. Remember the composite function? Those composite function, you do what? 1 over u, and then take a derivative of this u. I'll give you an example. All right, if I give you this problem, 2x's, you gotta take a derivative of this. Are you with me, class? So I do derivative is what? This derivative is same as 1 over what? 2x. That's the first thing. What's next one says? Take a derivative of which one? 2x. What's the derivative of 2x? 2. So that's why you get a what? 1 over x. Does everybody see that? You put the u, 1 over u, and then times what? U prime. This is what they're talking about right here. 1 over u, and then what? This is what? U prime. Derivative over u. So 1 over u, which is 2x. Derivative over 2x is what? 2. That's how you get 1 over x. Are you following me? All right, next one. I have this one. So what do I need to do? 1 over u, what's my 1 over u? This, x squared plus 1. I'm going to skip this part so I can put my du. What's my du?
2x.
2x. So I'm done. So 1 over, this is my u, right? Whole thing. So 1 over u, and then what do you do? U prime in the numerator.
Oh, okay.
Are you got it? Are you with me? Okay. So 1 over u, and then u prime,
Okay.
which give you this. Are you following me, class? Next one. I need to do this case. I need to do a product rule. Did you notice that, class? You cannot just do chapter 5 without doing what? Chapter 1, chapter 2, chapter 3, and chapter 4. Are you with me? Now I gotta do a product rule. Or, so what do I need to do? This one I can do 2 different ways actually. Let's just see which way I did it. And then I will show you another way too. They use a product rule, right? So x times what? Derivative of natural log of x plus, and then what? Natural log of x times what? Derivative of x. Are you with me? The product rule? The product rule, do we not remember? U times what? B prime plus what? B times U prime? That's what they have here. Are you following me? Just a regular product rule. So this is my first one, this is my what? Prime of second one. The second one times what? Prime of the first one. So x times derivative of natural log of x is what? 1 over x. Natural log of x times what? Derivative of x is what? Just simply 1. So when I simplify this, I will get what? 1 plus natural log of x. There's other ways you can do, not using a product rule. You want to try that? Remember the property 2? If it's, this is my what? Oh, this is x to x. So you will not know how to do it yet. Okay, never mind. They have to use product rule because you haven't learned that complicated derivative. You cannot do it. If this was a number, yes, you could do it. All right, this one. This is the example that I was trying to show you actually. If this is just a number, what can I do?
Move it to the front.
Move to the front. So I put the move to the front and natural log of what?
So you just did chain rule, you subtract it.
Yeah, they did chain rule. They can do the chain rule too. So they do what? 3 times natural log to the what? Second power, and then what? Derivative of natural log of x. So you get this. Can I do other ways if you wanted to?
Yeah.
What? Right? I can bring the power to air in the front. So what's my derivative of that then? Natural log of x is what? X. And then 3 is in the front. Oh, their answer is not same as mine, unless this is E. So did you notice that if I put this in the front, my answer is not same as theirs, because we got 3 and natural log of x, but we didn't have which one? The middle part.
I just got confused.
Yeah, don't worry about doing a power in the front.
This one?
So let's do this way for now, and then let me see the why they're not equivalent. Let me think about it, because I was expected to be equivalent. But I just did it, they're not equivalent. Did you see that? Because when I just put the coefficient in the front and take a derivative, I get only 3 and natural log x. I didn't have this middle factor. So let me look into it and then talk to you guys tomorrow about it, because I didn't think about that. On occasion, it is convenient to use log as a's in differentiating non-logarithmic functions. This procedure is called logarithmic differentiations. For example, find the derivative of this. And they're also telling you x is not equal to 2, so this is not going to be 0 there. Note that y greater than 0 for all x is not 2, so in natural log y is defined. Okay, that's what they say. All right, I'll show you an example. If you have this problem right here, okay? What I'm gonna do, I'm gonna put the natural log in the front each. Because trying to do this problem is much harder. But if I put the natural log in the front and front, I can make this problem into what? 2 parts. So I make this into a natural log. Does everybody see this 2 came from here? Right, 2, right? And then this is one, remember this one, I'm just going to write this one. Does everybody see this one? So I make it into 2 natural log of x minus 2 and then 1/2 natural log of this. Are you with me, class? Okay, now take derivative of that. Get this is the same as y, 1 over y, and then what? Y prime equal to derivative of this is what? 1 over y x minus 2 times which one? 2. What's the derivative of this? X squared plus 1. What's your 1 over u, right? And then u prime, which is what? 2x, you have 1/2. You're done. This is much easier than taking a derivative of which one? This one. You have to use this one as what? Quotient rule. And it's very complicated because you have a what? Square root, and you have a square. So you got a lot more calculations you got to do. But if you make it into a log function, this becomes a what? Much simpler. Are you following me? Okay. So now, I just combine this denominator together, then you get this. Does everybody see that? You multiply this by what? Since you only have x minus 2, and this one has x squared plus 1. So I will multiply this by what? X squared plus 1, and this by what? X minus 2, that's right. And that's what you get. I didn't show you individual step. When you multiply this by this, x squared plus 1 and times 2, which give you what? 2 squared plus 2. This is right here the same as what? 2 squared plus 2. What does this one give you? 2x that would be 2x squared minus what? 4. So do you get enough number here? 2 of that. Oh, you got 1/2. So divided by 1/2, what do you get? X squared minus what? 2. X squared plus 2. So you got 2. I don't have the same number as they have. What did I miss, class? Let me erase this one so we can see how they got the number. All right.
Substitute.
So we have x minus 2, and then what? X squared plus 1. So I will multiply this one by 2 times which one? This. Am I right? This denominator, okay, this denominator has what? 2 of this. So I need to multiply which one also? Okay. I'm multiplying by this. the next one up here, what would you do? Minus 1 times which one? Right here? All right, what do I get after you do that? You get a 4x squared plus 4 minus x plus 2. I don't get the same thing as they have.
You got this.
I have a 4x squared minus x plus 6.
Is there something else you can do to the problem?
No, this is, I don't think this is correct. Why don't you guys look at it and see?
Where did that other two come from?
Yeah, that's what I'm trying
At the
to.
top.
Hold on, you guys.
She had it.
Okay, let me rewrite this problem just so we can all clearly see. So this 2 goes in the numerator, so you have a denominator to x minus 2. Is everybody with me? I just moved this 2 to over here. What's the other one? So this is 1/2 of that, right? Well, actually, I can just do a cancel out this one. So I have x over, which one? X plus 1. So I want to make the same common denominator, which is x minus 2, and then what? X squared plus 1. So I will multiply this by x squared plus 1, and this by what? X minus 2.
Okay.
So far, so good?
Right.
So what do I have then? 2x squared plus 2, and then you have a what? Minus x squared, and then plus what? Plus 2. Because of this minus, are you with me? The minus apply here to become a minus, this minus apply here to become a what? Plus.
Still.
Well, what I have is what?
Plus 2x.
Yeah,
That
that's
should be
2x.
bad.
Plus 2x.
Plus 2x.
That should be
Was it
plus
2x?
Yeah.
Where?
At the,
At the end.
That's
Your
it.
two X's in front.
Oh! I didn't that's why I got it wrong. Okay, last 2 times, I didn't multiply x. I would keep leaving as what? Number. So, yes, I got it now. Do I get it?
Yeah.
This and that give you what? X squared, and this gives me a 2x. That give you what? Plus 2. Okay. Well, good to know it was correct. Okay. So did everybody see how I got it and how that's how you're gonna do the same thing? So we got this. What else do we have to do? All right. So I'm looking for which one? Y prime, right? So y prime is equal to y times all that. Does everybody see it? Simply multiplying what? Y here. That cancel out. You get a y over there. Is everybody with me? I know this is not your favorite thing to do. Algebra, like long algebra expression, is not your favorite thing to do, but we gotta do it, all right? So we have all this. But I'm not done yet. Why not? My answer has been tangible what? X. So this is your y. It's given. So I just replace y with what the y is given. This is your y. Remember the very first problem? This is your y. So I replace this y with a given y. Now you're done. But by the way, this is still much easier than doing a quotient rule. All right? If you want, you can try that and see which one you like it better. All right?
Alright.
But, yes.
So, the natural log of y, how does it turn into y prime over y?
This one? Okay, so y is a composite function, right? So when I take a derivative of this, remember I'm taking derivative of x. But the y is not just the y. Y is not just x. It's not just x. If it's an x, I would just do 1 over x, and then what? 1. So this is not the same as is this. Are you with me? So this means what? Take a derivative of that, which is x, and derivative of x is what? Happen to be 1. So I'm done. But this case, when I take derivative of that, derivative of natural over y means what? 1 over y, 1 over y, right? And then you have to do a derivative of y. What's the derivative of y? Y prime. That's why I put the y prime on the top. Does it make sense to you? Like this, the x prime happened to be what? Just the 1, right? Derivative of x is what? 1. That's why I just put 1. All right, so you're done. I'm not gonna go all the way here, okay? They go one more simplifying. What was one more simplifying? This and that, they can cancel out just because only one of them. And this, everybody see that? And over here, how many do you have? Half, and then ones, how many do you have then? 3 half. Did you see that? Well, this is another thing, 1 over u, derivative 1 over u. U is a composite function, so you need to do what? 1 over u, and then take a derivative over u prime. All right, take a derivative of that. What is it going to be? Derivative of natural log is what? 1 over u. First thing is what? All right. What's the derivative of cosine x? Negative sign. What is sine of a cosine? Tangent?
Tangent.
Yeah. Alright. So they will give you this. U and u prime. You got u is a cosine x. U prime is what? Negative sine x. And you're going to say x same as what? Tangent. We're almost done. So chapter 5 is a little different, but it's not much different. You only have like a special case. When it's x to the negative 1 power, they become a what? Natural log. Otherwise, you can just use your power rule.